Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Power System Stability and Control. Today we will discuss about the overall course, how we are going to manage it. So the outline of my presentation will be, I will start with the questions. Basically these are the questions that we are going to answer during the course. And then the course objectives are listed, and we will discuss them in detail. That will enable us to answer these questions, and according to these targets we have selected our contents for the course, the appropriate recommended references, then few more information about it, and then we will discuss about the two things. One is the software that we are going to use in this course, and the project. And finally I will end this presentation with the evaluation method. So I will take around maximum 10. So the questions that this course will address, the first is very simple. The first one is, so you should be able to very clearly state technically and accurately what power system is. The second question we will be addressing will be the stability and the control design of the power system, okay, and how we are going to do that. Question 3, we will redefine and figure out the stability definition in the context of power system. The question 4 will be focusing on the existing control methods in the power systems that we use. And finally, the fifth question is about what's new in this subject. We have heard that economics and environmental sustainability is affecting, and also the energy trading is giving us some competitive environment. But our focus will be mainly on the data analytics and utilization of the big data and how we can use it to avoid blackouts. And for that purpose, for example, some data sets are available. The grid data sets available on the cable for the grid stability estimation, so we will explore that as well. So these are 5 basic questions. Now there are some more elaborated questions. For example, what are the tools for the modeling, analysis and design of the controllers in the power system? So after the course you will have some good expertise in all these 3 areas. So it's about, the final question is, what will be our approach to study this subject? So in the next, explain it in detail. Number 1, we will focus on understanding the physical working of overall power systems and the core components in it. And we will use some usable mathematical models of the power systems that will help us in the stability study and to figure out the stability limits against different type of disturbances. Note that the disturbances may be different, and the same disturbance occurring at different time or different location will put different challenges, and also the magnitude of the disturbance itself. So we will discuss it in detail. The third step, after having this mathematical models at individual component level, we will develop the integrated mathematical model, okay, that will enable us to analyze the complete dynamical picture, right from generation, in which we use synchronous generators, to the transmission lines and up to the consumption, that is load. And once we have the whole steady state model, we will test them and see their performance against different disturbances. Having the integrated model, we will be able to study the overall system, and we will be able to tune the controllers so that the system remains in the stability limits. We will also explore the data-based analytical methods for the power system stability and control. So to answer these questions, the course objectives will be, the first course objective is to provide the knowledge of existing stability and control concepts for the power systems against different common disturbances. And this is done with the basic understanding of their physical phenomena and how the stability analysis and control techniques are implemented. right? The second is to provide theoretical foundations of the overall field of stability and control, especially for the, of course, for the power systems. And the third point is to introduce the student about the emerging trends in the stability and control. For example, how the data science and machine learning techniques are helping us. We will explore it more, and how the SCADA and other things are helping. So now it's better to further explain the objectives. So the theory and practice of stability and control of power system is challenging due to its interconnected large scale nature, and it's continuously have some many nonlinear systems, nonlinear components, and the dynamics is continuously varying, load is always changing. So we will see what comes from theory and how in practice it is implemented. The good thing is the basic understanding of power system components and their interaction at the steady state. So if we are able to study the whole system and model the whole system at steady state, it will help us to model and analyze the overall power system against different type of disturbances as well. So we will see that in detail. So the physical and operational understanding of power system components along with the mathematically derived analysis tools. Now this is the addition in which we will focus and utilize the swing equation, equilibrium criteria, stability and analysis programs. They will help us to providing the balanced methodology of studying the stability, and that will enable us to design and even tune the controllers against different disturbances. So this is an integration of the basic concepts and the practices. And the third objective that we have added will enhance the course applications to the recent advancements and integration of the learned concepts in SCADA systems for power systems. Like for example, the recent ones are PMU's units faster than the SCADA systems. So this course is designed for professional engineers as well as research engineers, and not limited to electrical power and electronic control domain. And so the course contents selected are: the first part is about the power system stability, its definition, classification. Next we will see how stability, the power system security and reliability are defined and how they are different from each other. And what are the assessment methods, security assessment methods for the power systems. And for the motivation, of course, we will see some worldwide blackouts, and especially in 2006 the Pakistan also had one blackout, and in other years as well. So we will see what are the challenges. The power system components and modeling will comprise the second part, in which we individually see what kind of models and we can use, are usable synchronous machines, what are the models for the excitation systems, the prime movers, governing systems, how the AC transmission can be modeled and used for the stability studies, and the power system loads. So the second part is about, the first part will elaborate the basic and discuss the basic stability definitions and related topics. The second part is about the power system components and their useful modeling techniques. And the third part is the core, in which we actually focus on the stability issues of the interconnected power systems. And basically there are two main phenomena that we are going to focus on. Like one is categorized as electromechanical phenomena, and the second is the electromagnetic phenomena. In power system there are other wave phenomena as well, but these are the two core phenomena that we are going to focus in this course. And within this phenomena actually lies the transient or angular stability discussion, small signal stability, torsional oscillations, voltage stability and frequency stability. So this third part is going to discuss a core issue of the stability. After knowing the stability against different disturbances, it's logical to go towards enhancing the system stability. So we will focus on where we will see what planning measures can be taken, how the stabilizing controllers can be developed and designed, power system stabilizer for example, and how to control the active power, frequency, and reactive power, and the voltage, and what are the preventive and emergency controls. Now by this time we will be ready to integrate some other renewable energy systems like wind and solar power plants, and finally the data science for the power system stability and control. So these are the course contents. So we can say 1, 2, 3, 4, 5, 6, 6 major parts. Recommended references for this include, since we are going to use many references, it's better to quote them. So B1 is the reference. B1 is the stability book by Michalowski. Second, B2 will be the power system control and stability by Anderson and Fawad. B3 is power system stability control by Kundur, well-known Kundur. B4 is the power system stability control by Padial. And B5 is the power system stability and dynamics and stability with Peter Sir and Pai. It's a recent one from IEEE Press in 2018. And the sixth book is about the big data analytics in future power systems by Ahmed and Trevor in 2019. And of course, these all topics or books will be supported by some research papers and articles on the not limited to the machine learning and data analytics on the stability and control, but also in other topics as well. We will explore some research. Here are some other information. My name is Dr. Mohammad Sabi, and our decided time is Thursday 2 to 5 p.m. online. Due to the COVID, we are in hybrid mode, recorded sessions and online question and answer sessions over Zoom. The lecture notes will be available on the LMS and will be shared. All the recordings will be shared with you. Now coming to the one aspect of the software. Due to the large interconnected nature of the power system, it's better to use some modeling and simulation tools of professional nature, and we have selected some tools and commonly used worldwide. They help you not only to understand the system, but also to contribute and participate in the professional ongoing work. So to understand the dynamical phenomena of power systems, computer simulations and softwares, but not limited to, for example, in MATLAB, PSAT, Power System Analysis Toolbox, that's very common. And we will also explore some Python-based tools like PyPSA, Python for the power system analysis, and the professional Power Factory that is very useful. And you can, if you get expert in Power Factory, so this will help you not only you can get so much work even online, and you can have some remote work on your part-time, for example. So these are the software that we target. They help us to understand and illustrate the ideas, the analysis and design purposes, and you will enjoy the whole course with the addition of such software. So it is highly recommended that you start utilizing and making use. We will do it. For example, for Power Factory functions, I just put few here, and you can see that see the electromagnetic transients. We can simulate the small signal stability, eigenvalue analysis, and in other system parameter identification, state estimation. So we will see arc flash analysis. So there are plenty of analysis, and some optimization, reactive power optimization is also there. So we will inshallah use this. Now project is a very important part of it. This course, completion of a project is needed for this course, and the project may consist of a survey of papers from literature or a research reports, and or it can be an independent investigation of a topic that you like. And basically, students, you are supposed to select the topic and discuss it with the instructor and the class for discussion. And the report for this project will be graded based on the following points. Number one is the originality and your critical thinking, how you are putting the things and what you are thinking, what solution and problems you are addressing. And then the technically how accurate you have put, and how accurate the details are. So this is also very important, how professionally you put the details and accuracy you follow. The third point will be about the scope that you define and the work you do. And the fourth is about the quality of presentation, how logically you put the things together, and how much clarity is there in the presentation, the neatness of the presentation as well as on the report. So this is the professional outcome of your work. And the output will be, we expect and highly recommend that you should write an applied research paper, or the outcome will be a technical report. This is very important that it's not it's not for the sake of just publication. It's very important when you write a good research report, you get more confidence, and you get reviews, and you start working with the people who actually prepare and design new solutions. So you will enjoy. Evaluation will be 10% quizzes, maybe 2 quizzes, 5 marks each, 10% homework, maybe 2 homeworks, okay, 5 each, and the project will be around 30%, and the final exam will be the 50 marks. Right? This is my email address, m.sabih@dsu.edu.pk. For any questions, please write to me. Thank you very much.